Friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Yes, everyone, just quickly tell me in the comment section whether my audio and visual quality, everything is okay. So everybody who is joining me live, just quickly confirm whether my audio, visual quality, everything is clear so that we can start with the session. Until then, let me tell you what is the ideal duration of this session. This session is going to last for approximately 45 minutes. And what is the agenda for today's session? In today's session, we are going to talk about some of the important concepts and questions related to the EMF and torque equation for your subject DC machine, for your topic DC machine for electrical machines. In this GATE Rankers Monsoon free course, I welcome you all once again. Just quickly hit the like button. Just like, share and subscribe to BYJU'S Exam Prep if you have not subscribed till now, so that you do not miss any of the important session from your favorite faculty. So friends, just tell me in the comment section whether my audio, visual quality, everything is clear. Without wasting much time, let us start with the session. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from ITBH in 2010, written a couple of books, and these are my areas of expertise. Before we start the session, a very important information for all those candidates who are very serious for GATE 2023 and who want to ace the GATE examination. In the very first attempt, your favorite Fanin sir is going to take a very important session, and that is going to be live on 26th of July 2022, and the timing is going to be 8 p.m. and he is going to discuss how you can get through with GATE examination in the very first attempt with a very good rank. Let us talk about the first question that we are going to see. He is saying the counter EMF of a shunt motor is 227. Counter EMF means he is talking about back EMF. Back EMF. So back EMF is mentioned here. Back EMF is mentioned here, 227 volts. First information. The field resistance is given. The field resistance is given as 160 ohms. And the field current is also mentioned. The field current, suppose it is the shunt field current. So this is going to be 1.5 ampere. Because it is a shunt motor, it is already mentioned in the problem. He is saying if the line current is 39.5 amperes, what is going to be the armature resistance? Let us first see the circuit for this DC shunt motor. This is going to be your armature resistance, and this is going to be your shunt field, which is connected in shunt with the armature. And this is going to be your DC supply side. This is the supply side voltage. This is going to be the back EMF. This is going to be line current. This is armature current. This is shunt field current. This is shunt field resistance. And this is armature resistance. Is it clear for everybody? Once you are able to draw this circuit, if you want to know what is the armature resistance, what is the best way of doing this? You can simply apply the Kirchhoff's voltage law. You can write the KVL equation for the armature circuit and you can easily find what is armature resistance. How you are going to write RA? It is going to be supply voltage, DC supply voltage V minus the back EMF divided by the armature current. Can I write this equation? Everybody, can you write this equation? Yes. Now in this equation, the terminal voltage is not mentioned in the problem. The back EMF is given, that is 227 volts, but the terminal voltage is not mentioned. Can you find it? Yes. We can find it because this terminal voltage is coming across the shunt field winding. Shunt field winding current and resistance are mentioned. So you can very easily find the DC supply voltage, that is ISH and RSH. What is the shunt field current? Shunt field current is mentioned as 1.5 amperes. And what is the shunt field resistance? I think it is 160. So just multiply this and you will get the supply, DC supply voltage. I think it should be is it 240 volts coming? Yes. Just confirm it. I think perfect. 240 volts. Yes. Yes, Mr. Vaibhav. Is it clear? 240 volts is the DC side DC supply voltage. The back EMF is mentioned. Now, how you are going to calculate the armature current? Now, see here. Armature current you can relate as the line current is equal to armature current plus shunt field current. The line current is given, shunt field current is given. Very easily you can find what is the armature current. What is the line current given? The value is 39.5 amperes. Line current is mentioned. Line current is the current which the motor is taking from the DC supply. So it is 39.5 minus, what is the shunt field current? It is 1.5. So what is going to be armature current? I think this is going to be 38 amperes. All the values you are having, just put it here and you will get the answer. Is it clear? Everybody just tell me in the comment section, are you able to follow this? Is it clear? If you have any doubt, you can ask me. See the next question. See the next question. The next question says there is a separately excited DC machine which is operating at 1200 RPM. 1200 RPM it is operating. It draws 100 ampere from the line at a terminal voltage of 230 volts. So terminal voltage is mentioned, line current is mentioned, and it is a separately excited DC machine. Obviously, it is going to be a motor. It is obviously it is going to be a motor, DC motor, because it is taking current from the DC supply. So it is behaving as a motor. The armature resistance between the terminals is also given. He is asking find the developed torque. Now please try to understand what is happening. First, I am going to draw the circuit diagram for the separately excited DC motor. This is the armature resistance. This is the DC supply terminals. And this is the separately excited field winding. This is the excitation given in the field winding, that is VF. This is the field winding resistance. This is the rheostatic resistance, that is the variable resistance put in the field circuit, so that if you want to have any variation, you can have it. If you want, you can assume it to 0. This is RH. This is RH. And this is your field winding having the current IF. Separately excited simply means, as the name indicates, that the field winding is going to be separated from the armature circuit. Because it is a motor, so if you apply a voltage V here, it is going to take some current, that is the line current. This line current is the same current that is flowing through the armature. So this is armature current, this is armature resistance, and this is the back EMF. Is it clear for everybody? Thank you so much, Mr. Mondal, for your love and appreciation all the time. What he is asking in the question? Find the developed torque. Now you see, we know what is the back EMF. Okay, we know what is the back EMF. What is the armature current? The armature current is also mentioned. What is the back EMF? Okay, back EMF is not mentioned. We know what is the terminal voltage. So can you tell me what is the back EMF? Can you apply the KVL equation here? Can you apply the KVL equation here, and can you tell me what is back EMF? Back EMF is going to be V minus IARA. What is the terminal voltage mentioned? It is 230 volts. What is the armature current? That is equal to line current. So line current and armature current are same. Line current and armature current are same. That is 100 amperes. That is 100 amperes. So this is going to be 100. What is the armature resistance? It is 0.07. 0.07. Just check this value. I think it should be 0.7. Okay, let me just check it once. Okay, 0.07 is okay, no problem. So it is going to be how much? 230 minus, it is going to be 7. So it is 223 volts, 223 volts. So you know the back EMF, you know the current. So can we apply this equation that whatever power is supplied to the armature, it is getting transformed or converted into the mechanical power. So what is the input electrical power in the armature? This is going to be back EMF multiplied by the armature current. How you are going to write the mechanical power developed? That is going to be the torque developed multiplied by omega. Now omega we are writing as 2 pi n divided by 60. What is this back EMF value? 223. What is the armature current? 100. This is the developed torque. This is 2 pi. What is the n value? The speed is also mentioned here. Speed is 1200 RPM. So just put this value here. 1200 RPM divided by 60. Just solve and tell me what is the value of developed torque you are getting. As per my reference, I think you must be getting as 177.5 Newton meter. 177.5 Newton meter. Yes, Mr. Khan, you're right. Is it clear for everybody? This was an easy question. Do you understand how I have established this relation? Do you understand how I have established this relation? This is very, very important. If you want, I can give you some idea. Suppose this is your, or let me take the example of both generator and motor so that you get the whole concept. Suppose this is your generator. This is the shaft of the generator. Now generator, you give mechanical power as input. So from where you are giving mechanical power? From where you are giving mechanical power? By using a prime mover. This is a prime mover. So once you apply the input mechanical power, there is going to be, suppose there is going to be a prime mover torque in this direction. And if your rotor is free to rotate, it will start rotating in the same direction. But definitely there is going to be flux linkages, EMF will be induced, current will be present, flowing, and there will be another torque developed because of the interaction between the two magnetic fields or magnetic fluxes. That interaction torque is going to be opposite to this prime mover torque, and this is what we are calling as developed torque. This is for the case of generator. This developed torque is responsible for giving you the electrical energy in the form of output. I hope you are getting this. That is why this torque is also called as electromagnetic torque. Electromagnetic torque. Is it clear for everybody? Similarly, we are having the motor action. Suppose this is your motor. This is shaft of the motor. In case of motor, what is the input energy? The input energy is going to be the electrical energy. This input electrical energy is again going to be giving rise to a torque, that is the developed torque. And suppose the direction of that developed torque is, suppose in this direction, randomly I am taking, this is the developed torque. Now if your rotor is free to rotate, the rotor will start rotating in the same direction. But if there is any load, mechanical load connected to the shaft of the motor, it is going to apply an equivalent opposite torque, that is load torque. So the direction of load torque is going to be like this. Is it clear? Now, whether it is going to be the case of generator or whether it is going to be the case of motor, please try to understand. This mechanical power at the input is going to give you the output electrical power. So for the generator case, can I write this equation? What is this? This is input mechanical power. So this is going to be tau d or Td multiplied by 2 pi n by 60. Simply I am writing omega in terms of n. This is the input mechanical energy. This is equal to what you are getting in the armature of the generator, that is generated EMF multiplied by armature current. So this is the expression you can use for the case of generator. Now for the motor, what you are doing, you are giving input electrical energy. So input electrical energy at the armature, what it is going to be? Back EMF multiplied by armature current. And what is the mechanical power developed? That is nothing but the torque developed multiplied by 2 pi n upon 60. Very important equation, very powerful equation. Lot of questions you will see in the GATE examination. If you have command over these, you can solve it. Yes, everyone. Let us go to the next question. Let us see the next question. Again, it is a separately excited machine. So, without drawing the circuit, can we do it? Yes. He is saying separately excited DC machine operating at 1200 RPM draws 100 ampere from line at the terminal voltage of 230 volts. Now, up to this point, this question is similar to what we have discussed in the last question. Now, armature resistance, this is also similar. Now, he is giving you the value of torque. He is saying when the torque is 300 Newton meter, what is going to be the speed for same excitation? What is going to be the speed for same excitation? Same excitation means what? The excitation given to the field winding is not changing. So basically he is telling you that field winding current is constant, or you can say the field flux, which is directly proportional to the field winding, this is also going to be constant. Is it clear for everybody? Yes, everyone. Now, if I am using the data that I have gathered in the previous question, if you observe it, when the armature current, suppose this was the first case, previous question, when the armature current was 100 ampere, what was the torque value you have got? I think it was 177 point something. It was 177.5. It was 177.5. Yes or no? This is Newton meter. Now this time in the second case, he is telling you, you don't know what is the armature current this time. Okay. But torque he is mentioning, torque he has mentioned as 300 Newton meter. It is given in the question. Torque is given as 300 Newton meter. So what is the first thing we can find from this information? We can find the value of armature current for the second case when the torque is 300 Newton meter. How we are going to relate the torque? What is the expression for torque? Torque you can write as K pi Ia. Now this K is a constant which is given as Pz upon 2 pi A. This is a machine constant. So number of poles, number of conductors and number of parallel path, everything is going to be constant. So K is going to be a constant. Now phi is already a constant. It is given for the same excitation and because it is separately excited machine. So the only variation is going to be the armature's current. So can you write T2 upon T1 is equal to Ia2 upon Ia1. What is T2? 300. What is T1? 177.5. What is Ia? It is 100. So can you tell me what is the value of Ia2? Everybody just calculate it fast. Everybody just calculate it fast. What is the value of Ia2? Hanif Khan is asking a very good question. See, he is asking a very good question. He is saying in the previous discussion, what we were discussing, he is saying, sir, in case of motor, what we are giving as input electrical energy, that must be converted into the torque or the mechanical power developed. See, there are certain losses also. Whatever you are giving as the input electrical energy, all of that is not going to the armature because there are some losses in the circuit. That is the brushes. There is a drop in the voltage at the brushes. There is a drop, voltage drop at the armature resistance. So because of all those losses in the electrical circuit, what you are getting at the armature is the back EMF and the armature current. Now, if you talk in terms of the mechanical power developed, again there is a problem. Because whatever mechanical power developed is finally not going to be available at the shaft. Are you getting this? That is just the interaction torque or electromagnetic torque. Are you getting this? The same problem you will find in case of generator. Because in generator, what you are writing is the prime mover torque. But actually this torque is not going to be directly available because there are some mechanical rotational losses also. Are you getting this? But this equation you can apply when you write in terms of the power at the armature, whether it is generator or motor, and you are writing the mechanical power by using the interaction torque. If you are writing in terms of the interaction torque or the electromagnetic torque, then it is going to be okay. Are you getting this or not? Is it clear, Mr. Hanif Khan? Are you getting this? Everybody? So what we were discussing, let us come to the next question. So what is the value of current you are getting? I told you to solve it, but you are not interested. It is not going to help you if I keep on solving it. Okay. You have to be active when you come for the session. You should be very active and enthusiastic, excited about it. Otherwise, there is no use of just sitting idle and watching this discussion. Ultimately, you have to do the action part. Is it clear? What is the current value you are getting in the second case? As per my reference, it should be coming as 169.01. 169.01 amperes. Now, if you have the current value, now very easily you can find the speed. Yes or no? Because you know, whenever we are relating the speed, how we are relating the speed? We are relating the speed with respect to the EMF. In case of motor, it is back EMF. How you are writing back EMF? We are writing back EMF as K phi omega. Now K is a constant, phi is a constant, so you can write back EMF is directly proportional to the speed. So now you can write, because you have to find the speed now. You have to write the speed as N2 upon N1 is back EMF for the second case, back EMF for the first case. N2 you have to find. What is N1? N1 is, I think, 1200 RPM. What is EB2? Now EB2 you can write as, listen. EB2 you can write as supply voltage minus armature current in the second case and armature resistance. What is back EMF in the first case? Already we have calculated in the previous problem, that is 223. What is the supply voltage? It is 230. What is the armature current? 169.01. 169.01. What is the armature resistance? 0.07 divided by 223. Just tell me what is the answer you are getting for speed N2. As for my reference, it must be 1174. Just cross check this. Are you getting the same value? Are you getting the same value? You understand the procedure or not? Torque is mentioned. With the help of torque, we are finding the armature current. By using the armature current, you can find the back EMF. You know the back EMF in both the cases, you can relate the speed and you can find it very easily. One of the most usual question you can see in any examination when machine is going to be asked from DC machine. See the next question. There are some corrections I want to have in this particular question. There are some corrections I want to have. It should be 0.011. Just change it. It should be 0.011. Is it clear? I am writing it here again. He is saying the resistance of each turn is 0.011 ohms. Okay. Mr. Hanif Khan is getting 328 RPMs. There is some problem there. Just check your calculation. If you are doing this, you are getting how much? Let me just confirm the value. Other candidates, can you solve it? Only one candidate is doing, so that we can cross check it. What is the value of back EMF you are getting? How much value you are getting this? As per my reference, you must be getting the back EMF for the second case as 218.17. 218.17 volts. Now you see there is some calculation mistake, I think, Mr. Hanif. Okay, just cross check it. That is a problem because other candidates are not doing it. Let us see the next problem. So this problem is related to a separately excited DC generator. Let us keep on writing because a lot of data is mentioned in this problem. Let us see how we are going to solve it. Number of poles are mentioned as 12. Separately excited DC generator has a wave bound armature. Wave bound means number of parallel paths are 2. The armature is containing 144 coils of 10 tons each. What is the number of coils? 144. What is the number of ton in each coil? Tons per coil. That is 10. The resistance of each ton is also mentioned. Resistance per ton. This is how much? 0.011 ohms. Flux per pole is also mentioned. Flux per pole is also mentioned. That is 0.05 Webers. 0.05 Webers. And the speed is 200 RPM. And the speed is 200 RPM. What is the resulting counter torque on the shaft of the machine? He is asking you what is the counter torque. Counter torque is nothing but the electromagnetic torque or the interaction torque. Is it clear? Now, if this much data is mentioned in the problem, listen very carefully. Number of poles, number of parallel path, coils, turns, resistance, everything is mentioned. Flux is mentioned, speed is mentioned. So, what is the first thing I am going to do? Listen very carefully. I can very easily find the value of EMF induced. It is going to be simply Z pi N by 60 and this is P by A. Flux is given, speed is mentioned, number of pole is mentioned, number of parallel path is mentioned. The only thing which is not mentioned is number of conductors. Now, how we are going to find the number of conductors? Please listen very carefully. Listen it very carefully. What is the total number of coils? What is the total number of coils? Let me just check the question once. What is the number of coils? Yes. Number of coils is 144. 144 is the number of coils. In every coil, how many tons are there? 10 tons. So, what is the total number of tons? 144 coil multiplied by 10 tons. For 1 ton, how many conductors are required? If you want to have 1 ton, ton means one closed path, something like this. This is 1 ton. For 1 ton, how many conductors you require? This is AB and this is CD. It means 2 conductors will give you 1 ton. So, there are 144 coils. Every coil is having 10 tons. So, this is the total number of tons. Total number of tons multiplied by 2. You will get the total number of conductors. It is going to be how much? 2880. Is it clear? So you have all the values. Can you calculate what is the EMF generated? Yes. You can calculate what is the EMF generated. Okay. Now I have to find the torque. The same thing we are doing. Listen. Same thing we are doing. We are writing EMF generated multiplied by armature current. That is the electrical power in the armature, because it is a generator. Okay. And what is the input mechanical power in terms of interaction torque? This is developed torque multiplied by 2 pi n upon 60. Now the problem is EMF you have calculated. Speed is also mentioned. 200 RPM. Yes. Speed is also mentioned, 200 RPM. You know what is the speed? Speed is 200 RPM. You know what is the EMF, but you don't know what is the armature current. Can you find it? Yes. If you can draw the circuit for this separately excited generator, because it is a separately excited DC generator. Can you draw the circuit? Yes. Separately excited. This is armature. External terminal. Supplies means, sorry, supply, it's not supply because it is a generator. Load is going to be connected. And it is mentioned here in the problem. See, if a 1 kilo ohm resistor is connected to the terminals, it means this separately excited generator, a 1 kilo ohm resistor is also connected. So here it is going to be 1 kilo ohm, and that is the load resistor. Is it clear? Suppose this is the terminal voltage. This is the armature current. This is the load current. This is the armature resistance. The field circuit is separately excited. This is the variable resistance, rheostatic resistance. This is the excitation in the field winding, and this is the field winding resistance. This is RF, this is VF, and this is the current in the field winding, something like this. If you know what is the EMF induced, can you apply KVL in this loop? Yes. So what you can write as IA. IA is going to be total EMF plus the load resistance plus armature resistance. EMF you have just calculated. Armature resistance is given in the question. Load resistance is given. So can you calculate this IA? Yes, you can calculate this IA. So you have calculated the generated EMF also. You have calculated the armature current also. Speed you know. Very easily you can calculate the developed torque or interaction torque. Let me tell you what is the value I am getting here. If you solve it correctly, I am just giving you some reference values so that you can do it. The EMF induced is coming as per my reference, the EMF induced is coming as 2880 volts. Okay. The armature current you must be getting as, there is one more twist in this problem. I will tell you how to calculate because the armature resistance is not given directly. I will tell you, please wait. 2.86 amperes is the armature current you will be getting. But there is a problem. I told you very easily how to find the armature current. The problem is load resistance is there, 1 kilo ohm. But armature resistance is not directly mentioned. If you read the problem carefully, he is giving you the resistance of each turn. Now here you have to apply the knowledge of winding. The given winding is a wave winding. So there can be only two parallel paths. There can be only two parallel paths. How many number of coils you are having? 144. In each coil, how many number of turns you are having? 10. So this is going to be total number of turns because he has given you the resistance of 1 turn. So first I have to see what are the number of turns in one parallel path. Are you getting this? So 144 number of coils and every coil is having 10 number of turns. So it is 1440 into 10. So this part is going to have 1440 divided by 2. 1440 divided by 2. This is the number of turns. This is the number of turns. What is the resistance of 1 ton? Listen very carefully. The resistance of 1 ton is mentioned as 0.011. So this is going to be the resistance for each of these parallel paths. But because it is a parallel combination, so it is going to be the armature resistance is going to be 1 by 2 times 1440 divided by 2 multiplied by 0.011. Is it clear, everybody? Are you able to follow this? This step is clear for everybody how we have calculated the armature resistance if resistance of 1 turn is given. Are you able to follow this? Because it is a wave bound machine. So what is the number of parallel paths? It is going to be 2. So what I have done, I have divided the total number of turns into 2 equal parts. Number of coils are 144. In every coil there are 10 number of turns. So 144 into 10 is 1440. Divide by 2. 1440 by 2. 1440 by 2. Multiplied by the resistance of 1 ton, that is 0.011. You will be getting the armature resistance value. As per my reference, it is 3.96 ohms. If you do the calculation part, you will get it. Is it clear for everybody? Are you able to follow this or not? I'm not getting any response from your side. So be little active in the comment section so that I can get to know whether you are able to follow this or not. Only one candidate is active. Why it is so? Yes, everyone. Is there anyone having any doubt? You can ask me. Yesterday also I told you, you have to start speaking for yourself. Others are not going to take responsibility of you. If you have any problem, if you want to improve, you have to be active. You have to tell me if you have any doubt in the class itself. Let us see the next question. Now this is one of the most classical question. There was a generator operating, DC shunt generator. Various parameters ratings are mentioned. Suddenly the belt is going to be broken. When the belt is broken, now the same generator is now operating as a motor. Okay. Why motor? Because the current direction has reversed. Initially the generator was supplying current to the okay, Mr. Khan, what you are solving, I don't know. Always write the complete information, na? Because there is a delay on YouTube. When I say something, when it reaches to you, and when you write something and when it reaches to me, there is a delay. Anyways, are you getting that? What is the whole idea of this problem? Now he is saying there is a 100 kilowatt belt driven DC shunt generator running on full load at 300 rpm, 220 volts bus bar, continue to run as a motor when the belt breaks, taking 10 kilowatt. Whenever the power rating is mentioned, you please try to understand he is trying to give you the information of current, either supplied or taken. Yes or no? Supplied or taken. Armature resistance is also mentioned, field resistance is mentioned, brush voltage drop is also we have to take into account. Now what he is asking, what is the speed in case of motor? What is the speed in case of motor? Now first thing you have to understand, if it is a shunt motor, listen very carefully. EMF is K phi omega. K is a constant, Phi is directly proportional to the shunt field current, which is given as V, that is the supply voltage, divided by the shunt field resistance. Just now we have seen the circuit for DC shunt machine. Until and unless you change the supply voltage or you change the shunt field winding resistance, the shunt field current is not going to be changing, and if the shunt field current is not changing, this field flux is not going to be changing, and field flux not changing means what? You can directly relate the EMF and the speed. So EMF and the speed I am going to relate like this. If you want to make this problem little easier for you, so you have to have a little bit of practice for both the case of generator and motor. So Vaibhav, चंदन सर इज रिमेम्बरिंग यू. सर आप आई जाइए तो अच्छा है, थोड़ा बच्चे आप प्लीज कम. सो फ्रेंड्स, प्लीज वेलकम वन ऑफ द लेजेंडरी फैकल्टीज इन आवर डिपार्टमेंट.
हेलो एवरीवन, हाउ आर यू?
चंदन झा सर.
So I think you guys are basically enjoying the machine.
Yes sir. Few motivational words sir.
Sir, everybody in the this is the initial phase of the any preparation GATE 2023, because 2023 exam of GATE exam is basically very far. So whenever the people are basically starting their journey, they are always energetic. So no, you can say that motivational, all things are basically required. That is required in between, in month of September, October and November. So I think you guys are basically enjoying the journey, and after a long time sir, मैं इस channel पे भी आया हूँ. Right. So all the very best guys, and I remembering the few students, that is Vaibhav, Hanif. These students are already the old student, right, into the various batch. They have attended the session, right? सर शुरू करिए आप.
सर जिस तरह से ये लोग दे रहे हैं आंसर, उस तरीके से पता चल रहा है दे आर सीरियस स्टूडेंट्स.
सर राइट नाउ people who will come into the session, they are very much serious. Even they are 5, 10, 12.
सर आप कमेंट सेक्शन देखो ना, सिर्फ 2-3 बच्चे लगे पड़े हैं और प्रॉपर सॉल्व कर रहे हैं, मतलब कैलकुलेटर लेके, पेन नोटबुक लेके, और वो भी रात में 10 बजे जब लोग.
जबकि यही चीज सर अगर कोई एंटरटेनमेंट वाला चल रहा होगा ना, वहाँ पे 5K 10K आपको दिखेगा, बिकॉज नाउ डेज द पीपल आर नॉट दैट मच ऑफ सीरियस as we can expect into the initial phase.
सर लेकिन सर उसका रीजन है, मैं आपको बताऊं सर. गेट में कुछ ही बच्चे रैंक 1 ला सकते हैं. एंटरटेनमेंट तो करोड़ों लोग कर रहे हैं सर, एंटरटेनमेंट तो कोई भी कर सकता है, बट रैंक तो 1 ही 2 लोग लाएंगे.
डेफिनेटली सर. सो गाइस एंजॉय द सेशन, राइट?
थैंक यू सो मच सर. थैंक यू सो मच. So friends, just now you have seen Chandan Jha sir. Anybody, can you say just hi to sir? You have not welcomed sir. Anyways, so friends, let us quickly understand how we are going to relate the speed. The speed in case of motor and speed in case of generator. What you have to write? The back EMF in case of motor and the generated EMF in case of generator. Now see here. How you are going to write the back EMF in case of motor? You have to apply the logic of what? Logic of sink or the load. What is going to be source here? In case of motor, what is going to be source? The DC supply is going to be the source. So how you are writing the back EMF? Supply voltage minus armature current in case of motor multiplied by the armature resistance. But we have the brushes drop also. So we have to include the brush contact drop also. Is it clear for everybody? This is how I am writing it for the back EMF. If you are not that much prepared, you can draw the circuit. Okay, you can draw the circuit and you can confirm it. For the generator, again we are going to apply the logic of source logic. What is source logic? Everything is going to be provided by, every drop is going to be provided by the generator itself. So EG is going to be what? Supply voltage, terminal voltage plus drop in the armature resistance plus brush contact drop. Is it clear? Brush contact drop is mentioned already. It is given as 2 volts. You know what is the armature resistance? You know what is the supply voltage? So the only thing that you have to do in this question is you have to write the current in case of generator and motor action. Can you tell me directly what is going to be the current in case of generator action? Yes. You have to write the load current in case of generator plus shunt field current. Can you write the armature current in case of motor? Yes. This is going to be the line current in case of motor minus shunt field current. I hope you are able to follow this. How you are going to write the load current in case of generator and line current in case of motor, because ratings are mentioned. Ratings are mentioned. In case of shunt generator, what is going to be the load current in case of generator? Rating is given as 100 kilowatt divided by the voltage. What is the operating voltage of the bus? It is 220 volt. Solve it. What is the line current in case of motor? What is the rating mentioned? It is 10 kilowatt. So 10 kilowatt divided by the line voltage 220. Now shunt field current is already mentioned. Shunt field current you can find. What is going to be shunt field current? Supply voltage is mentioned. What is the shunt field resistance? 60. You can solve it. Can you do this or not? At least say yes or no in the comment section. You people are actually scaring me. The way comment section is running, it is like a horror movie for me. Okay? Only one candidate is answering. I don't know why. Is it clear, friends? So let us stop here. I have some more problems. Yes, you're right, Hanif. I will just tell you what is the answer to this question. You can just cross check it. It must be 278.8. You must be getting C as the correct option for the speed in case of motor. So the other problems you can try back home as part of your homework. Okay, so we don't have a problem. That's good. So this is all from my side, friends. Thank you so much for joining me live in the discussion. I hope you are enjoying the session and you are getting some benefit out of it. Stay connected to BYJU'S exam prep for all these important videos, and do not forget, tomorrow also 8:30 p.m. Tomorrow also 8:30 p.m. 8:30 p.m. I'm going to talk about the torque equation of induction motor. Torque equation of induction motor, only on BYJU'S exam prep. Thank you so much. Take care of yourself and let us meet tomorrow. Thank you so much. Best wishes. Thank you.